So that brings us to our second keynote of ICSE this year, and it gives me great pleasure to introduce Margaret-Anne Storey from the University of Victoria. So Peggy is a professor of computer science in the University of Victoria, and she's also a Canada Research Chair in the human and social aspects of software engineering. I think it's fair to say that Peggy is a great example of a modern academic. If you look at where the interesting research problems lie nowadays, it's less in the disciplinary silos and much more in the crossover between different disciplines. And certainly, Peggy has done lots of research over the years, looking at the social and human aspects of software engineering, working not just within software engineering, but within different disciplines. She's also done that outside the software engineering community, so she's co-director of the Matrix Institute at the University of Victoria, which is an institute for cross-disciplinary data science, and she's applied those ideas in domains as varied as the environment and climate change, smart cities, and mobile health. And also in her own work, she's worked quite a large amount of her time in biomedical ontologies. She's worked with the US National Cancer Institute and also with the National Institutes of Health and the World Health Organization. So a very good example of working across disciplinary boundaries. And she's also really, keen and excited to get her research out there into the real world and has forged partnerships with industry and non-for-profits as part of that. She's also the recipient of a number of awards. So, for example, she is a member of the Royal Society of Canada's College of New Scholars, Artists and Scientists. And now this, for those that don't know, this is a network of researchers across Canada where they've identified the emerging leaders in research across all disciplines in Canada. So that's a great indication of her reputation and her standing in Canada. The other thing about Peggy, though, is that she's, of course, very well known to this particular community, to the software engineering community. She's been on the editorial boards of TSE, of TOSM, of IEEE Software, and of the Empirical Software Engineering Journal, so pretty much done it all. She's also been the program chair of FSE. And if you were to go on DBLP today and just filter out the ICSE publications, you will find that she's been a co-author on 26 ICSE papers over the years, which is quite a phenomenal number, and I'm incredibly impressed by that. So she knows our community really very well, and that's one of the reasons why she was asked to give her talk today. She's going to talk to us about the impact of software engineering research and force us perhaps to kind of self-reflect and question ourselves a little bit. So I think it's a very apt topic for the world in which we live today, and will give us some indications of what the state of software engineering research is in terms of its impact on the world. So without further ado, I'd like to invite Peggy to the stage and look forward to hearing your talk.
Wow, that's amazing.
Good luck.
Thank you. Good morning, everybody. It's my pleasure to be here. Thank you, John, for that introduction. Didn't really sound like me to me, but we don't always think about all of those things at the same time. And thank you, Joe, for inviting me. There are still some seats at the front. However, the advantage that people have at the back is that you don't get to see how small I really am or how short I really am. So I can just pretend I'm very tall up here. So I'm going to be talking about questioning the impact, as John said, on the software developer. And it's a different view than we've seen before, and I hope that you join me in this talk and think about some of the things that I raised. That's a really good start. I guess I'm not plugged in after all. And I'd like to start off by talking about this image. How many people here recognize this image? Okay, it's not that maybe well known in computer science or software engineering, but it is a picture. It's called the Lion Man. And it's a picture of a sculpture, an ivory sculpture from 35 to 40,000 years ago. It was found in a cave in 1939. And it's the oldest artifact that really shows how humans developed this ability to be able to imagine something that doesn't exist yet. So that real ability to be able to imagine art, to be able to imagine theories, to be able to imagine technology innovation started with this. And I wanted to start with this image because software developers are incredibly imaginative. A lot of what we create as developers are new artifacts and new ideas. And we work together with other people to create those artifacts and to create the software. And part of our job, at least for many of us in software engineering, is to develop an understanding of how developers work, how they collaborate with each other, and how they go through this creative process. But we also create a lot of tools. And this is a really frightening diagram. But this represents the constellation, the very complex constellation of tools that developers have to use pretty much on a daily basis to do their job. And of course, we in software engineering, we add to these tools, right? And we create even more tools to automate what they do and to try to help them in their job. And in fact, even some practitioners are blogging lately saying that one day maybe we're going to automate everything and the software developer will no longer be relevant. Using AI, we can automate much of their work. Do you guys think that's where we're going? No. Maybe some people. So I think we need to be careful that we don't automate too much. And even Elon Musk, I know people poke fun at him a lot, but he has this quote from Twitter. Yes, excessive automation at Tesla was a mistake. To be precise, my mistake. Humans are underrated. And so I'm calling, I guess, a little bit through this talk to our community to be careful that we don't underrate humans and underrate software developers. In fact, if you ask developers, and there's lots of surveys, I've been involved with some, and lots of you in the research community have done surveys, this one's from Stack Overflow, where we ask developers, what are your main challenges to productivity? And normally the top things that they mention are not their tools or lack of tools, but there are social and human aspects such as distracting work environment, going to too many meetings, poor management, being tasked with non-development work, interruptions, and somewhere down the list you eventually see engineering tools. So this is a view that's very familiar to all of us. Software engineering is a socio-technical space. And so it's this bringing together where we need to understand the human and social aspects and how those intersect with technical aspects. And these, of course, are all set in a particular context. Maybe it's a company context, or maybe it's open source. What happens, though, if we focus too much on one side than the other, we end up with what's called a productivity paradox. Right? So we had a question about the Boeing 737 MAX yesterday. That's an example of a paradox, perhaps a little bit on the technical side. But an example in software engineering, you could think about continuous integration. It, in theory, works really well, but in practice, if developers don't adopt it and don't write the test cases, or somehow try to game the system or ignore the warnings, then maybe the process and the project doesn't go as well as you think. Of course, it goes the other way as well. If we focus only on the human aspects and not enough on the technical aspects, such as adding a lot of developers to a late project, then, and without taking into consideration the technical dependencies in the project, we can also have a challenge. So what we need to really do is focus in the middle. And I bring up this example of CodeFlow, which is a code review tool, which was developed from the ground up. So it's a homegrown tool from within Microsoft, developed by engineers for engineers to support their code reviewing activity. And I put a link to a blog post or an article on this that talks about how they really took into consideration the technical and the human and social side to arrive at this tool, which is at the intersection of human, social, and technical aspects. And so if we're going to do well in our community and do well with our research, we need to focus on this joint optimization of both sides. Here's another tweet. I like Twitter. So I learned a lot from Twitter, actually. So hypothesis, the AI-HCI relationship is cyclic because AI booms focus on building software that's smart enough to guess what the user wants without explicitly asking. HCI then comes in to clean up the mess, bring the human back into the loop, and restore some control to the users. And the tweet also had a graph that showed this cyclic activity that's going between AI and HCI, and how we have a boom of AI and then a boom of HCI to clean up that mess. And so what I'm trying to do through this talk, and there are many in the room that I know feel the same way, but I'm looking at bridging the gap between those of us that tend to focus maybe more on just the human and social side or on the technical side, and bring us closer together. Because I'm worried that this might happen, okay? That if we have too much focus, especially with this AI boom that John was saying yesterday, AI and SE was the 6th most popular topic, and it's a new topic, right, to our conference. I missed, where were the human and social aspects? Were they on that graph? Were they ahead of that? They were below. Okay, so I want to fix that a little bit. Because I have seen this looking at the research, but I do need to share that I do have a little bit of a biased view, in case you haven't picked it up already. But this is something I see, and so I wanted to explore that, and I'm going to do that through this talk today. So here's the outline of the rest of my talk. So I want to question our impact on the research that we do on software engineering on the software developer. I'm not necessarily going to answer that, but I'm going to hopefully put enough out there to tease and provoke some discussion on whether we're doing a good job or not. And I'm going to do this through 3 ways. Through looking at our paradigms, our worldviews, and we have different worldviews in our community. Through looking at the types of contributions that we create. And through looking at the methods that we use that focus on software developers. Now, I know others have done this over the years. Mary Shaw, in 2002, had that fantastic paper that looked at questions, results, and validation approaches. It was repeated in 2016 by Thiessen and Williams et al. And there are other papers, Selkowitz and so on, and impact papers that have also looked at this. So this is my, I guess, or because this is a collaborative effort, our view on looking at this. So it's a little different than these earlier works. We could maybe discuss those differences later. So before I get into the main part of my talk, I do want to acknowledge that a lot of what I'm talking today is really the result of a lot of amazing people that I get to collaborate with. And the people that are on this slide over the last 2 to 3 years have directly impacted my thinking, or directly impacted how the results that I'm going to show to you today that tease about this question about questioning our impact. And I couldn't even list everybody on here, but it's a shout out to all of these people. So in terms of paradigms, let me start with this. So what is a paradigm? I'm going to start with this quote, because I really like this quote. So a paradigm is a shared worldview that represents the beliefs and values in a discipline and that guides how problems are solved. So what does that mean? So this is a picture of Montreal. So if you walk into the city, what do you see? So my husband is a forester, and whenever we go walking through a city, he will notice the trees, right? Other people will notice the buildings. Daniel German, that's sitting there, will notice the restaurants, right? So we see different things based on our worldview and what we care about. But it's more than what we see. It also affects the kinds of problems that we think are important. Do we care about improving transportation, or doing something about poverty and homelessness, right? And it also affects the ways that we go about solving those problems. As well, it would influence the kind of data that we collect, or the kinds of data that we don't collect, which can have a big impact downstream. So let me give you a simple version of different paradigms. There are other versions that are more complicated, and I know most of you know this. I'm just setting the stage for something. So Cresswell puts forward these sort of 4 different paradigms, or 3 different paradigms. The first one is a post-positivism kind of paradigm. And this is the one that I think is most familiar to most of us. It's where I started when I went into computer science, for sure. It relies on the scientific method. It's this notion that reality is out there objectively waiting to be measured in some way. It involves theory verification, but also theory falsification. And it focuses a bit more on using quantitative research strategies over qualitative, but a post-positivist could also use qualitative strategies as well. An example from the medical field here might be trying to understand what drug should you take. right? So somebody would look at evidence about a drug and would look at results to make a decision, is this drug going to help me get better, than another drug, using statistics. The constructivist approach is a little different. So constructivists tend to think that the world is subjectively experienced, and that collaboratively and along with other people, they create this sort of subjective understanding of what the world is, that you can't just objectively measure it. You can never remove your bias of what's happening in the world. And in fact, these biases are expected, and they're expected to be made explicit by the people reporting this. And constructivists tend to favor qualitative over quantitative methods. So a constructivist might be interested in a question such as, how do we improve or how do we study the experience of children in a pediatric hospital? And such an understanding would require a lot of different stakeholders to come together and bring a rich understanding of what those children experience. You couldn't get it from just a survey or from data. Change-oriented view is what's called the advocacy participatory view. And this really involves researchers who care about making a change in the world or maybe in a company. And this approach tends to be highly collaborative. It's shaped by their political and social lenses, and they tend to use a mix of methods. So an example of this would be somebody going into a city such as Montreal and saying, how can we ensure that everybody has a private care physician? So their focus is on making change. So I took the liberty, and I did ask these folk for permission, to identify some personas from our own community that I think somehow represent these different views. So I think we all know Tim. Anybody not know Tim? The newcomers probably don't know Tim, but you will know Tim, especially by the end of my talk. So Tim is a post-positivist, and I asked him if he was okay with that I would use him. He collects a lot of data. He uses a lot of statistics. He cares about, the size effects and whatnot. And he said that he's a knowledge, how did he put it, a knowledge optimist and a knowledge doubter. So it really represents that notion sort of a post-positivist. Carolyn Seaman is a constructivist. So she really cares about processes and people, and goes into the workplace and goes into companies and study how they work and builds rich theories and rich understanding of how those activities happen there, with a view to making an improvement in some way. Margaret Burnett, in her recent work in particular, is following this advocacy approach. So she cares about making change with GenderMag and making sure that our user interfaces are appeal to people with more diversity. So the question is, what are all of you? So I'd like you, so I'm a teacher, right? So early morning in the morning, how do you wake everybody up? You have to do a quiz. I should have told you that before I showed you the different views. But there's a hint here. So are you a post-positivist? Are you a constructivist? Or are you an advocacy participatory researcher? And I'm going to switch over to another screen so that you can see what we're getting in here. And if you're struggling with answering this, think about what kind of papers you like to review. Okay, which ones do you go, I'm going to do those first. I'm going to leave those other ones to the end, because I don't know as much about those other papers. And, I'm probably going to bring down the Wi-Fi network, and Joe, I'm really sorry. But, this was kind of a ploy to make sure that people couldn't do their email and would have to listen to me for the next half an hour or so. So we leave this a couple of minutes. I let it go to 2:50. So if you need to vote, vote quick. Okay, next one. What is your predominant worldview? So do you consider yourself a post-positivist, or a constructivist, or more of an advocacy researcher? Okay, cool. Who's winning? Oh, very nice. Hey, we have good balance here. This is interesting. I'm going to come back to this later. You got 300 voted. Okay, we'll take a look at this again later. So we do have actually fairly more balance than I thought, but we have a lot of post-positivists in the audience. So the point is that there isn't a right approach or a wrong approach. We need all of these views to work together to make really important change in that intersection, that socio-technical intersection, so that we study not just technical aspects, but we also understand how those tools are used by people. And so think about that later today. Now, some of you, the astute of you that know Cresswell, would have been thinking, well, he also offers us that pragmatism view. So I don't know how many teachers are here today, but you know when you do a multiple choice question with students, and students don't know the answer, they always choose C, right? And so pragmatism is always like, you know, that's what people choose when they don't really want to commit to anything. So I didn't give you that option. But I actually know that many of you are pragmatists. You're very sort of problem-oriented, you care about practice, you care about making changes, and you will use and probably try to adopt methods that fit whatever the problem is that you have at hand. Nevertheless, we do tend to have a leaning towards being more comfortable with, you know, data-oriented or quantitative strategies or qualitative strategies from a constructivist perspective or from advocacy perspective. So I asked my office mate, Neil Ernst, if he was a pragmatist, because I was looking for a good example to put up here. And he said, how many people know Neil? He is the funniest person on the planet. Okay, I just have to let you know that. Very dry sense of humor. And this was his response to me on Slack. He says, I'm the publisher, perish, whatever works kind of guy. So he knew I was doing this for this talk. But actually, he is somebody that really does switch quite elegantly and uses different perspectives and has good understanding of these different perspectives. Okay, so that was paradigms. So moving on to contributions, what kind of contributions do we see? And by types of contributions, I don't mean contributions in software testing or compilers or debugging. I mean a different kind of contribution. And I mean the kinds of contributions that come out of different scientific domains. So what I'm not going to talk about much today are the formal sciences, the philosophical and mathematical foundations and contributions that can come from these kinds of sciences. I'm going to talk more about the explanatory and also the design sciences. So the explanatory sciences are what we see in social sciences and also in the natural sciences. And so we see descriptive theories coming out about why things work the way that they do. As well as predictive theories. If we change this intervention, what will happen? The design sciences, on the other hand, are used typically in medical field and also in other engineering disciplines and information systems, and they concern coming up with some kind of an intervention or some kind of a solution, or sometimes it's called an artifact, that you can design to solve a particular problem. So it's really focused around a solution to a problem. And I'm going to zoom in on these two because these are the area of empirical research, which is my focus of a lot of my talk. And I'm going to zoom particularly into design sciences because I engaged with some colleagues from Lund University on a study of design science and how design science can be used as a lens for framing different kinds of research contributions. So Per Renison is here. This is also work with Emily. And this work actually took place over 3 years as I was a Lisa Meitner guest professor at Lund, and it took a long time. And I don't recommend that what we did you try at home. I really don't. It took way too much time, but it was really fun. So the first thing that we did was we tried to get a very, very deep understanding of the design science literature, and we read lots and lots of different papers to come up with our own kind of conceptualization of something that we felt would be a better fit for trying to understand software engineering research. This is one of the papers that we built on. So Hefner is very well known in design sciences, and his sort of view of it is that it consists of 3 cycles. The first cycle is this relevance cycle, where you try to understand what are the requirements for a particular problem or environment or a set of stakeholders. The second cycle involves designing an artifact or that solution that I mentioned before, and really understanding, does it work within that design cycle before going back to the relevance cycle and seeing, does it actually fit the environment and the stakeholders it's aimed at? And then finally, the knowledge base and rigor cycle involves when you're designing something, did you really pull from the knowledge base what we know already? And do you bring back to the knowledge base the knowledge that you get from the relevance cycle and the design cycle? So I can't go into all of the papers that we read because that would probably take about 12 months, right, Per? But I will just go now to our sort of conceptualization, which isn't a departure. It isn't philosophically different from many of the papers that we read. It is just our way of viewing these concepts because we found it more helpful to use this representation to understand software engineering research contributions. So we divide, so as I said, design science is about problem and solution, these problem and solution pairs. And we divide this conceptual space into practice and theory. And the way that our empirical research, our research occurs, are arrows between these different stages. So I'm not sure if this is going to work now. Problem instances, bottom left. That's when you're in practice and you're working with real stakeholders and you see that they have a particular problem. So an example of this, I'll mention Carly's research. She was looking at engineers at Microsoft and trying to understand how engineers, the struggles that they have when understanding the build process, and what can she do about that. And from that sort of specific instance of understanding the challenges that developers have with build, she then comes up with constructs and reasons that this problem that she sees probably also exists in other companies and with other engineers. And then from that generic version of that problem, we then say, well, what kind of solution is going to help with that problem? And then from that solution, we then actually implement something, a solution instance. So we instantiate it, and then we empirically evaluate that solution with a real problem instance. And the cycle continues. And in our conceptualization, I mean, I started our discussion with problem instances, but you could start with an existing solution instance and think, what the heck's this thing doing? What's Slack doing, right? And then kind of pull out the constructs from it and then see, could we use it in a different way or in a different context? This is a simpler view of the same thing, the problem-solution pair. And here, this view actually highlights 3 different places where our empirical work may occur. So we may have empirical studies where we try to understand what is this problem from specific problem instances. And that may be the research contribution in a paper. The next I guess, part of our empirical work is going from problems to the solution. And here we take our requirements and we come up with a solution idea. And then we may evaluate the solution independently from the problem instance, perhaps using, simulated data, or maybe just using other approaches. And then we may take that solution and then validate it with real problem instances, maybe the ones we started with or maybe other ones. Okay, so any paper that you look at could somehow, we feel, be represented through this view of design science that involves empirical work. Now, another important concept that we added to our view of design science is this notion of a technological role. This is borrowing this concept from Van Aken. It's also sometimes called a design role. And the technological role is really this theory fragment that is grounded in the knowledge that we get from coming up with a solution and applying it to a problem instance. So people are going to pull out their laptops now and start reading email because I said technological role. Don't. It gets easier. Okay, here's an example of a technological role, which I said is a theory fragment. So to reduce errors in open source projects, use continuous integration. Okay, it's a very simple one, very high level technological role. They could be at any level of abstraction, but I give a simple example. And what this relates to is, if you like, the template for the technological role. So to achieve an effect, to reduce errors in a given context, in this case, in open source projects, use continuous integration, in this case, use or do intervention. Or it could be do not do this thing, right, to improve something. So we also came up with 3 evaluation criteria. We didn't make these up, actually. I mean, we pulled them, right, from the research literature on design science, and we felt that these 3 were kind of the most pertinent to the work that we were doing in trying to understand our software engineering research. And the first one involves relevance. So design science is very much grounded in this notion that there is a stakeholder that you're actually trying to solve a problem for, and there's a context, and that there's a particular problem instance that you know is important and that should be fixed. So that's relevance. In terms of rigor, rigor applies to anywhere that you do empirical work. So if it's on the level of problem understanding, maybe you don't, though. Maybe the problem is known and you don't need to do that step, right? Or at the level of evaluating the solution independent from a problem instance, or at the level of applying a solution to the problem instance. And then the final thing is novelty. That's the most fun one, actually, when you're reading other people's papers. What is really novel here, right? So you would hope that for a paper that truly fits with the whole design science notion is at the level of the technological role, right? What is that theory fragment that we take away from that? But of course, not all papers may arrive at that full technological role. They may be more centered around problem understanding. So the novelty may be, what did we learn about this kind of problem? Maybe we gain an insight into a problem in software engineering that we didn't know before. Or maybe we gain some insights into a solution, or maybe into an evaluation technique. So novelty can actually come in many different ways. So we took these different ideas, the technological rule, the problem-solution pair, and these different empirical places, or I guess where empirical methods may occur, and these three criteria, relevance, rigor, and novelty, and we created a visual abstract template. And then we tried to apply it not just to design our studies, but also to evaluate our studies. And we took this template after a few iterations, and we applied it to 38 papers. And we applied it to ICSE distinguished papers from 2014 to 2018. And we tried to use this lens, this template, to see, is it useful in helping us understand what are the contributions in these papers? And we actually tried this out in a workshop before we did the activity ourselves at ICSE 2017. And we gave this to academics, and we gave them some of the best papers. Oh boy, were they a tough crowd. And then we ourselves, there were 5 of us, spent quite some months reading the papers, coming up with this visual abstract. And then what we tried to do, so we had a visual abstract representation. We did do some member checking with some of them, with the authors. We then tried to see, well, what kinds of clusters of papers? What are the different kinds of contributions that come out of these 38 papers? So I'm going to go through these 5 clusters. So the first cluster really highlighted the whole kind of design science cycle. So I was mentioning Carly's paper, where she looks at trying to understand how engineers understand distributed builds in complex systems. So that's an example of starting with the problem instance, then going to a more conceptual or abstract version of that, to a solution abstraction, and then back into a tool that she built, a visualization tool. So at her design construct level, she reasoned that a visualization might help engineers understand their distributed builds, and then we built the tool and then applied it with real developers in the company. So that's one example of going through problem solution. The second starts partway through. Okay, the problem is already known, right? Like, we know in our community that there are these problems, right, that we need to solve. So we don't need to go into a company and study this problem. So we know that the problem exists, and then we do some research and imagine, right, new solutions, and then evaluate that solution. So this is sort of the solution and validation cluster. And out of 38 papers, we had 7 of these. Then there were other papers that started more on the solution side and focused more on the solution rather than on validating it to problem instances. There was evaluation, but more at that solution evaluation that I showed before, rather than going back to specific problem instances. And then we had descriptive papers. So these ones, the design lens, science lens, helped us see that they were descriptive papers really easily. but that's kind of where it stopped, in understanding, research. For example, the research I did with Husios, did I pronounce his name right? That where we looked at pull requests in GitHub and tried to understand what are the challenges, what are the practices, right, that developers face when trying to integrate changes. And then from that, we came up with challenges and practices. So that's an example of a descriptive paper. And then there were these other papers, the meta papers, which aren't really about helping developers, but they're about helping researchers. So a systematic literature review could be an example of a meta paper. Or one of these papers was Janet Sigmund's amazing paper on external and internal validity paper, which was talking to us, right? Not talking to developers. And then what I'm going to do here is I'm going off script a little bit with the paper that we wrote, and I'm going to sort of reason a bit about rigor, novelty, and relevance, and think about how these criteria fit with these 38 papers. So definitely rigor. These are ICSE distinguished papers, is really good. Novelty, pretty good. That's still good. And A is really good, right? We tell our students that all the time, right? And then relevance, I struggled with this. I gave it an F. Okay, but that is not because I think that the work is not relevant, but because looking through the design science lens, it is focused around involving stakeholders. So the clever student would say, your marking rubric is wrong, right? All of our research should not involve stakeholders. And you're probably right, maybe. Maybe we'll continue that thought throughout the rest of the talk. So why did I give an F? I gave an F using this design science lens because only 13 of the 35 papers actually consider stakeholders at all in their paper. Remember, 3 were meta. That's how we went from 38 to 35. So 5 of the 8 studied developers or other stakeholders. For the problem construct, those were pretty, or the problem solution, sorry, those were pretty good. We had 6 of 13. But for the solution validation and solution design, those were more done not with real stakeholders. So that leads me to thinking about, and leading into my next part of the research, well, what are the methods that we use, and how do those methods involve stakeholders or developers in our research? And so that's what I'm going to talk about next. So this is a framework we're putting forward to describing the different kinds of research strategies that we see in software engineering. And now I'm back at UVic, and I'm describing research that I do with my colleagues at UVic, in particular my student Courtney Williams and Irini and Neil Ernst, where we're trying to understand what research strategies we use and how these research strategies directly impact or involve developers in some way. And the first thing that we do is we separate the non-empirical strategies with respect to the developers from the empirical strategies. So the non-empirical involve formal theory, methods, but also those meta papers. On the empirical side, with respect to the software developer, there are 4 quadrants here. I'll start with the respondent. So the respondent strategies are the kinds of things that we do when we do interviews and surveys with developers. The lab strategies, actually I'll show this on the next slide, involve either lab experiments or studies that we do with developers or other stakeholders in a lab-controlled environment. In the field, we may do a study, some kind of case study, again, involving our stakeholders, or we may do an experiment where we try to control the environment or some way. And then the last one is what we call data strategies. So these are the strategies that do not directly observe developers or involve stakeholders or survey them, but rather use retrospectively gathered data, or maybe just-in-time data, to understand what it is that the developers are doing. This kind of method is called in silico in the medical field, where you don't actually do anything with tissue or with human beings. You just look at the data. And these methods are incredibly powerful, right? Because then you don't have to harm people, right, to do these studies. So they use previously collected data to understand, right, perhaps how a new drug could work, looking at biological pathways. So another thing we borrowed from Runkle and McGrath are their quality criteria. So field experiments are very high on realism. However, if you're doing a lab experiment, it's not so high in realism. Or if you're doing a survey, the developers are not in the field and they may forget, right? They may report what they did differently. So field strategies tend to be high on realism. Respondent strategies tend to be high on generalizability because you can reach out to a lot of people, potentially, not always. So this is an abstraction, right? It's not, you can't say for sure that every method fits into one of these quadrants and is this way. And then from McGraw, we also borrow control of human actors. Or really, I should say, control of the variables that may come into play when you have human actors in a laboratory or field experiment. So in those settings, you can control these other variables that may somehow affect the human actors in the study. And then down on the right-hand corner, we have precision. So the data strategies are really good at allowing us to have good precision and good control over the data that we're using in our studies. I'm just highlighting here that 3 of the quadrants, you'll notice, all involve human beings as the unit of observation in those studies, right? And the data strategies do not. You might also wonder how this relates to our personas from the different paradigms that I mentioned later. There isn't a one-to-one mapping here, but there is a tendency. So Carolyn Siemens would tend to do field studies, right? And Tim may tend to look at data, or maybe do, I'm not sure if he does lab experiments with people, but certainly with data, I know he does. Just a couple of examples of the work that I've done that I've already mentioned, just to say why we made the choice that we did. So with the study where we tried to create a visualization to help engineers to more effectively understand their distributed bills, we started in the field with understanding what were the challenges that they had. We built a solution. We iteratively deployed it there so that we could understand, is this solution heading in the right direction? And by deploying it, of course, we gained more insights into the problem that we were trying to understand. And then we also did a control lab study just to see what would happen in a control situation. The research with Husios, with GitHub and looking at pull requests and the work practices and challenges there, we actually started with a smaller study that looked at some of the data from the GitHub projects, which we then used to help with the survey part and help inform and drive our survey. And our primary method, the second one, was the survey that we did. And through this survey, we were able to understand where the work practices and the challenges that we saw were these more generalizable across many GitHub projects. So we took this approach, this lens, it's another lens, the method lens, or research strategy lens. And my student, Courtney Williams, God bless her, for 2 years of her life, she read 253 ICSE papers. We think we have it tough as reviewers. And you can't get the kinds of insights that she got from just reading the abstracts. She had to read the whole papers to try to understand, and actually a lot of our team, we also read many, many of these papers as well. We tried to understand, could we categorize the methods that are used in these 253 papers? And so we did that, and this is what we got. Is anybody surprised by this? Oh, darn. You're supposed to be surprised. So it seems that in our community, we use a lot of the data strategies, and relatively few, so this is over 3 years of ICSE, relatively few lab, field, and respondent strategies. And we have some that are just only formal theory, or they're formal theory and other methods. I'll get to those in a minute, and some that are the meta. I'm not going to focus on those. And zooming into this, we see that if we think about McGraw's criteria, that we're achieving very good precision in terms of the data, right, or the technical artifacts that we're studying, but we don't have great control over the variables that may come into play when actually humans and developers are involved. And realism and generalizability, well, depending on the study, you can argue that those are pretty good, or maybe they could be better. Again, it depends on the question you're looking at. So zooming in on these data studies, we had 195 of them. Many of the papers actually, but I think 46 used triangulation, so reported more than one kind of research strategy. And focusing on the data strategies, 37 of these data strategies use triangulation as well. And so this shows a bit of a graph that shows how many of each of those papers used a particular kind of strategy, right? So 26 of the data papers also, or no, not 26, sorry, 7 of the data papers also did a field strategy. And 12 of them used a survey maybe, or some interviews as well, to back up their findings that they got from their data. So let's just look at the data-only papers that didn't use another method, 158 of these. And so we went back, my colleagues and I, and looked at this a little bit through that design science lens, but not the whole thing, because that is really hard. So we look at it just in terms of which of these papers are descriptive, so which of the papers bring some kind of a theory, or maybe even a predictive theory, but there's no solution developed, versus the papers that bring some kind of a solution. And you can see that I think about 85% of them are solution papers, rather than descriptive theories. So we have a lot of creative energy in our community, where we have a lot of ideas on ways that we can improve the tools that we're building for developers. But looking a bit more at these 158 papers from the 253 that had no human research subjects at all as part of the unit of observation, we wondered, well, you know, maybe they don't need to have people. Maybe these papers are all really focused on technical artifacts, making them more efficient. You know, the human is out of the loop. These techniques are completely automating what the developers do. And we don't need to ask developers, is this going to work for you? Or is this a real problem? And so we went back to the papers and we read them all, and we found that 110 of these 158 papers start off their paper with, if we build this tool, developers will be more productive in whatever it is that they're doing. I'm not going to pick on anybody. Because I've done it too. By the way, I've written lots of data papers. And so this is interesting. Some of the papers even said, you know, we build this tool and future work involves doing a user study. And you know, that totally makes sense, right? Especially for particular papers that are looking at the feasibility of a new approach. Like many of the AI papers, for example, we're still early, right? So let's try this out first with our data and understand if it works before we bring developers into this, perhaps, right? But I put out there that at a community level, maybe we have too much focus on papers that just look at the technical side and don't look at what happens with developers. So that's something I put out there. Maybe you agree, maybe you disagree. You get a chance to do that later, by the way. So there are also papers from within our community that have looked at this issue as well. So the Secret Life of Bugs paper by Jorge Aranda and Venolia, they found that just looking at data only was not a good way to understand how developers coordinate around bugs. Parnan and Orzo, they took dozens of automated debugging techniques and looked at the assumptions that were made in these papers and brought these techniques to industry and found that those assumptions that many researchers thought held true did not actually hold in practice. This was a really important paper. And Pearl, a Turing Award winner, has this to say in her book. It's a great book, by the way, The Book of Why, that you are smarter than your data. Data do not understand cause and effects, humans do. And I think that this is important because often, I've done it myself, right, where I've spent a lot of time looking at data traces from GitHub and Stack Overflow, and then tried to understand why it is that developers are doing the thing that they do, and then going, oh, why don't I just go ask them? Actually, the beginning of my career was this, okay? I created visualization tools. Man, I thought they were amazing. and I did lab studies. And then I went to developers 3 years later. I still graduated, thankfully. I went to developers 3 years later, and I said, what do you think about my tool? And they said, lovely, but it's not solving the problem that I have. I'm like, oh, okay. And that was actually when I kind of pivoted a bit in my research and started looking more, studying developers. So just to wrap up where I've been, you've been really patient because I know there's a lot of stuff in this talk. So we started with talking about the paradigms, the different kinds of paradigms that we see in our community. We saw that there are different views here and that maybe different perspectives are better suited perhaps to understanding human and social aspects, but we need both because our field is socio-technical. We saw that the contributions that we get, that we have these different kinds of contributions and they're all valuable and they're all needed, but they focus, again, on different things. And we saw at the method level that we have a lot of data strategies, right, in our community. And maybe this points to an imbalance. And maybe we wonder why we have so many data strategies. I'm actually not almost finished. I was just lying. But you can stand there. Okay. I mean, I'm getting close. So what can we do about this? So I put forward a few ideas, but I really invite all of you to think about if you agree this is a problem, and also to think about what do you think we could do as individual researchers, as students, as newcomers to the field, as reviewers and authors, what we might do to shift this impact. So the first one, let me go back to paradigms. So I was general chair of MSR, all the data papers. I love that stuff, you know. I loved being general chair, and fantastic, open-minded community. And one of the things that I heard in the discussion from MSR is, how come we're not talking to the people that are on the other side of the wall? You know, the chase people, the people that are studying, you know, the human aspects. Maybe we should be talking to them. And there's also potentially a silo a little bit between industry and research. So I put Microsoft on the slide because I've been collaborating and consulting with Microsoft for the past few years. And one of the things that I learned through very close collaboration with them is that practitioners are researchers too. They do the same thing we do. They just do it faster. And they maybe focus a bit more on relevance. But they come with hypotheses, they come with ideas, they run experiments, they write reports, they write papers. And it seems that if we could somehow close that gap, we might, you know, be able to understand the impact of our work a little bit faster and have a bit more impact. I want to do a shout out to Jo. I'm surprised she didn't put this in her opening slides. But she spent about 7 weeks, she claims she took vacation somewhere in there, going through the 300+ papers for this program. And what she did was she tried to create this blended program that we have. And I know she had help also from her co-chair. Sorry, I should acknowledge you guys as well. But this is the picture of the cute cat. She created this blended program that brought together the industry and technical track papers. And I know that it involved a lot of you to make sure that the papers were in the right place. And by doing so, we have more opportunity to see the kinds of things that are going on in industry, as well as the kinds of things that are going on in academia. So shout out to Jo. So another point that maybe we can think about at this paradigm level is that when we assign reviewers, we tend to assign them, you know, based on, are they software testing? Oh, sorry, don't do that again. I won't do that again. Sorry about that. My badge says software testing at the top. Apparently, I ticked software testing. And I have done testing work, but it isn't what I would have put at the top, right? We tend to assign based on the topics, right, that we tick, or the papers that we bid for. But we don't all read the papers, so we're not all sure yet which papers we should be bidding for. Maybe we need some way to know what are the worldviews that are represented in this paper, and to make sure that we have a balance of different kinds of perspectives coming to that paper. So I got caught out recently. I did a study. I'm kind of a constructivist, actually. I'm sort of a reformed post-positivist, but I flip back into post-positivism all the time because I love data. But I did this study really with the constructivist point of view, and I submitted it to a conference. It was rejected, so I rewrote it, and I rewrote it to appeal to post-positivist reviewers. And then I got a constructivist reviewer and said, why the hell are you writing this paper like this? Oh my God, right? So, you know, thinking about that as researchers, like, it was a real lesson to me. Just be true to myself, right? And just be true to ourselves, be what we are, and hopefully over time we'll get more appreciation, right, in our community about these different views. Also thinking about reviewing criteria. They're really good, the reviewing criteria that we have for this year. But you know, they get interpreted differently by people with different worldviews. So for some people, verifiability is about, you know, having an artifact, right? But if you're a constructivist and you've done focus groups in an organization and you're looking at sensitive things, you can't have those artifacts that other people can replicate and reuse. You can have some kinds of artifacts, and you can use those to verify that the researchers did a good job. And by the way, yes, we should be doing a better job at that. But it's not the same thing. And reviewers sometimes get confused about that. And replication is definitely important, but also triangulation is important so that we hit those different criteria across the spectrum. Now, I'm not saying a single paper should do all of the things, but if a paper does a couple of things, we should recognize that because it probably won't go into as much depth on just one study. And also things like audit trails, member checking, these are things that are important to more qualitative strategies that a lot of researchers maybe don't realize. And the other way as well, it goes in the other direction. I'll talk about that in a minute. So thinking about methods, so what I didn't say was when we did the study of the 253 papers, we also surveyed authors, and many of you replied and told us which strategies you used, which helped us validate our categorization, but you also told us why you used methods that you did. And so this quote on the left says, well, I would have conducted a field experiment, but we didn't have subjects readily available. And you know, that is really true. So this is a shout out to industry to also become involved with us and say, you know, I'm happy to work with you. You will get benefits. You won't always learn the things you thought you were going to learn, but you'll learn other things that are useful. And another author said, we took the standard approach that would typically be reported in a topic conference. So they look at all of the papers and they go, well, if I do one of those, I'm going to get an ICSE paper, right? So I don't know if that's what we do, but I was speaking to a colleague of mine from the Chi, or InfoVis community, actually, and he said he wanted a Chi paper. Chi is computer-human interaction paper. He's brilliant, this guy. He submitted 7 papers, all rejected. He's a constructivist. And so he was speaking to a colleague of his, and she said, just do a perception study. Boring as heck, but it'll get in. And so he did, and it got in, right? So you have to be we have to be careful as a community that we're recognizing that there are these different kinds of papers and that they are valued. And actually, if we collaborate together, and so sometimes I feel that there's a tension in our community between people that do the soft stuff, you know, and the people that do, you know, just the technical stuff, right? And that isn't the approach that we should take at all, that we really should collaborate together. Actually, over the last few years, my collaboration, I'm going to call out Tom and Chris, has been fabulous because they know so much more than I do about the data mining methods that we were using. We weren't using data mining, sorry, the machine learning methods that we were using. And I learned so much from them. So if we go into the field, we can come with actionable results. We can study not only adopters of our solutions and learn how they adopt it, but we can also study why they don't adopt it, right? So if you work with somebody that cares about the field study, you'll get that kind of result. And yet if you use the data strategies, they're scalable, they're repeatable, and they're unobtrusive. And that's really valuable. So they can be done quite early on in a research process. And more than that, if we work together and we work in really, really tight loops and we work with industry, then maybe we can get access to telemetry data from industry and use that as probes, as just-in-time probes, to go talk to the right people and maybe do surveys or observe what they're doing. And again, bring that power of diverse methods to our findings. And then the last point is about the kinds of things that our communities value. So in our community right now, there's a big push towards having open data, yay, a big push towards having replication and reusability, fantastic. And we have these badges that show that. And these badges perhaps aren't so important as external motivators, but the way that they're really important is that they show to people new coming to the field or to ourselves that if I do this thing and I take the work to, you know, keep my data and have it available and have my scripts available, that other people can build on my work, which is why we do research, right? So that other people can build on it. So these send a fantastic message. And I think we need to do more of this, and maybe even broaden a little bit. So I put out some suggestions of, I'm using the metaphor of badges. Maybe we don't really need badges per se. But maybe we could have, some kind of recognition that this paper that studied a problem instance, came up with a solution, and evaluated it with real stakeholders, and then articulated the finding from their study in a clear technological role, that theory fragment that other people could link to other related technological roles, that is like, yay you, go you, for doing that. My student is actually trying to distill technological roles from a suite of papers on continuous integration. And, it's really valuable to do that, but sometimes you have to do a lot of work to pull them out. Triangulation. Yeah, you're going to lose something in a 10-page paper. You're not going to be able to report all the things, right, if you do a couple of methods. It's hard. And, the other thing is humans are really messy, right? They're messy to study. They're unpredictable. You just, it's time-consuming. There are ethical issues to concern about. But if somebody does that, then we should value that, right, that effort that they went to do that. And in this age of AI, if we don't study humans and we don't think about, the impact of ethics and biases and so on that could come into our data, there could be some issues there. Is the thing developer tested? Did real developers use it? Even a couple. I often say that in my reviews. And industry collaboration. Is there an industry collaborator? So the impact project from some years ago showed that the papers that have an industry collaborator are more successful in terms of their citations. So maybe just a badge rather than a different track could do that. Thank you. So I'm going to leave you with this closing thought. And it's easy for me to say because I have tenure. Sorry. I think as a community, though, this is more thinking about our community and our changes that our community could do. I think we need to write less, think hard, and imagine more. Because imagining is what sets humans apart from machines, right? So with that, I'm going to move to discussion. And we're going to do a little Mentimeter thing. So if you still have Mentimeter going, I'll just go forward and then I'll come back to this slide. Oops. There it is. Oh, you guys are so fast. So this is the question. So if you're shy to come up to the microphone, you're not like Lutz, you can answer, if you like, how do you think we could improve our impact in software engineering research? And you can, interpret what I mean by impact in any way you like. But I'm going to go back to my slide, my last slide. Oh, we're going to show a few things. We'll gather those and share those later. So with that, I'll go to questions, discussion.
So Lutz has shown us how to do it. If you want to ask a question, you just walk up to the mic, and so take it away, Lutz.
Peggy, thank you. This was very definitely my favorite ICSE keynote ever.
Thank you.
And I'm fairly sure I will say this in a year as well.
And now for the hard questions.
There are many, I need to mention two reasons. There are many. One is that you ask us to write less. And another is that, the keynote was so completely free of cynicism. That was brilliant.
Oh, there was a little in there from time to time.
My question is, are you aware of any trembling emotion present in the ICSE steering committee already to implement changes that will make ICSE more balanced with respect to the worldviews?
I'm not on the steering committee, so I don't know that. But that's really good to hear.
Thank you.
Yeah. That was an easy question, Lutz.
back here.
Oh, hey there. My name is Reed, and I guess I would kind of consider, first off, amazing talk. And I would consider myself, I guess, sort of an advocate, or like the participatory paradigm, right, if I had to box myself, right? But I did have a question for you about open data, right? Because for a lot of the studies that I conduct where I work closely with human subjects, my first priority, of course, is to protect those subjects, right? And I actually had questions from people wanting to get access to more of the data. Now, surveys or the like can be more anonymized. Interview data is a little bit more tricky to work with, right? And that was a problem, I think, with an MSR, a really good MSR paper that was well received. But that was a question that came up about how do we manage that data? Because there's the empirical data, which is easier for me to share. And then there's all this messy human data that gets a little more complicated. So what's your perspective on that?
You know, I think that that is a really important thing to look at. I don't know. You know, I think that that's something as a community, maybe we could have a workshop on that. I know that this topic, I don't know where Tim is, it's going to come up in the Rose Festival today. You know, yeah, sorry, Tim. Everybody knows you now. But it's a very, very important technique. I mean, there are strategies in other fields too that we can look at and we can borrow from the social sciences, from the nursing community. So the nursing community really has a good handle on this, you know, dichotomy between qualitative and quantitative strategies. In fact, their call for paper separates them and recognizes in the way that the call for papers is phrased that there is this difference. And so they're treated differently, and I think that could be a community that we could look at. To be honest, I think a lot of us are kind of getting away with not doing enough due diligence on that, because I know I started as a, you know, post-positivist computer scientist, and so I just kind of became this social scientist when I became disillusioned along the way with what I was doing. But yeah, excellent question. Let's do it.
Okay. Thank you very much. Good talk.
We'll go to Ida.
Ita Richardson from Leroy University of Limerick, Ireland. Fantastic talk, thank you so much. I'm glad I rushed the walk to get back here. So what I'm particularly interested in at the moment, as you're aware, is around diversity.
Yes.
And that when we talk human, we're talking not like having aggregated rather than disaggregated data. And I really worry that we are not learning from the medical community, whereas it's now well recognised that because they didn't look at male and female, we have a lot of problems that exist in drugs, side effects for women are suffering because it was men that the subjects were. So I have a real concern that as a new human moving forward group, constructivism and participatory, that we really have to look for female subjects, for example. And then I think if we start to do that, we start to look for other diverse groups as well. So I'm really strong on disaggregating the data. So I'm wondering what thoughts you'd have on that.
Oh, I have a lot of thoughts on that, actually. Absolutely. I mean, you know, there are, I mean, I love the way Margaret Burnett says is, you know, that there are more differences, you know, between us as individuals than between the genders. And so I sort of want to follow with that. But I've noticed in my research, and even at the time that I spent at Microsoft, that there are just different people have different worldviews. And you have to take that into consideration. And there does seem to be, you know, differences between the genders as well. So I even see it in the research community. I didn't go into the Chase room because I was general chair and I was trying to do my job here. But, you know, I usually feel more comfortable over there because there are more women in that workshop than in MSR. And so we see it at the research level, but we also see it in companies that women tend to approach problems differently. I don't think I have the backup slide, but I had a slide that showed from the Stack Overflow survey, go look at this and scroll down. There's a question where Stack Overflow asked the developers, how would you like to see Stack Overflow being improved? And they separated the responses by gender. And the women tend to say things like communication and being nicer and so on. And the men that answered the survey tend to focus more kind of on the algorithms and the technical side. And, you know, we see this over and over again. So absolutely, you're right. But I mean, some of the challenges is that, and Bogdan, I know, has a tool for this. When we look at data from open source, we can't always easily see gender, right? And women and men hide their gender. In companies, a lot of companies don't want you to look at the data through the gender lens because they're worried about that. So we have a long way to go. I think a lot of political and social forces to look at before we get there. But you're absolutely right. We should keep our eye on that ball. Yeah, good question.
Hello, I'm Danny Dick from Oregon State University. Peggy, thank you so much for an inspiring keynote right here.
Thank you.
So I really liked your messages. You called us to action to work closely with practitioners and with industry. So from your vast experience of working with industry, what are some of the insights that we can do to increase our chance of starting a creative and a productive collaboration with industry?
Yeah, I think the big thing is to listen when you go to industry. Like, academics use a lot of big words, right? So Brandon Murphy was on my slide because he taught me how to present to industry. And Laurie is great at this, actually. He said, you have to present like Laurie when you present to people in industry. Get rid of all of that. Like that technological rule thing, oh my God, that would be like off the slide so fast, right? You know, anything that is, you know, talking in our language and not talking in their language is a big thing. But really listening to what their needs are and giving back. Like the biggest thing that I've done with my industry collaborators is I don't always think about the paper. I mean, it's very selfish of me to say that because I have tenure and I don't really care. I didn't even know I had that many ICSE papers, so, but you know, that's not what drives me. So I don't worry about the paper, I worry about helping them and then see if the research comes out. But that is a very selfish perspective. For students, when I have students that are working with a company, I have to steer it towards, okay, but you know, what is the research here? And how can we both win, right? What is that win-win? So that takes a little bit more effort, right? But I think listening, looking for the win-win, you know, giving to them, explaining to them what it's involved in, reaching out. Dana Damien is fantastic at working with companies. You should talk to her. She seems to have it really figured out how to engage a lot of different companies. So yeah, learn from people that do it well.
Absolutely. Yeah, what I heard you saying, it's serving industry and listening to them. What's your favorite question when you go to listen to industry and find what's their pain point?
You know, I never start with a question. I pretty much listen. And then I'll start to ask questions. I usually listen. Okay. Sorry, I know that. And then the question that I ask is tailored to what I hear, right? Like, what is it you're having problems with, right? Or can you explain that to me, right? Can you show me? I have a great example from part of the collaboration from Microsoft where, you know, part of what I give to them is telling them about different ways of doing studies. And so one of the researchers there was interested in studying, I better not say too much because I don't know how much permission I have, but I suggested to him to use the contextual inquiry technique from HCI, where you sit down with developers and you pretend you're the apprentice and they're the masters and they teach you what they're doing. And by doing that, you don't get the fiction that they tell you about in the interview afterwards. And he learned so much from he did about 12 of these. I couldn't believe it. He did it way faster than any grad student I'd ever had done. He did 12 of these in a few days. And he said, oh my God, I have so many actionable insights from sitting down and using my laptop. And he was able to show to other people in the company, here is the pain that I saw. Here it is. This is what our engineers are suffering with. So it isn't always just sharing knowledge, it's sometimes just sharing advice. Yeah, sorry, it's not a really good question, but I'm kind of like my brain is starting, or answer, I'm not good at, my brain is starting to turn to mush a little bit, but I'll think about that some more.
Thank you so much.
I hope that helps.
So Gregor, Yvonne, and then Ahmed.
Yeah.
It was a good question, I didn't mean that.
Maybe I'm here. Maybe I'm
Yes.
here.
Hi.
Okay. Hi. The talk was not bad. But I'm wondering whether you answered my questions about ICSE. Why I see so many papers on the, let's say, on the programming level, on the test level, and less papers on a higher level of software development, like in architectural things. Because my guess is that if I work more on the architectural level, I have less data available which I can use to justify my insights in the paper. So it's much easier to write a paper on testing than writing on architecture. So I have the feeling, maybe I'm wrong, I have the feeling that if you don't have data available for what you're doing, don't go to ICSE.
Yeah. Well, I don't want to get into the politics of different topics, okay, because I'm standing up here and it's just me. But I will share with you something related to this. And I think it's a bit of a wake-up call for our community, what I heard. So I presented this at another university in Sweden, Karlskrona. Anybody here from there? No. Okay, this actually works out. There's nobody here from there. So, and I gave the talk and on the methodology matters part, you know, the method choice. And they kind of sat there and I thought, these guys are bored. What's going on here? You know? And at the end I said, so, you know, what do you think? And they go, well, you didn't tell us anything we didn't know. That's why we don't submit to ICSE. And you just reinforced it. And I'm like, oh, that wasn't the point. Right? So, yeah, some researchers are aware that, you know, the kinds of work that they do is hard to submit to ICSE. Yeah, and a lot of it involves kind of the higher level. When you use humans, it's really hard, right? Yeah.
Yvonne.
Yes, thank you very much. This was actually, I think, the first talk where I saw, or keynote talk where I saw Chase on the slides in ICSE. And I'm very proud of that because I'm from the Chase community. And I have to actually open up to, because you have been responsible for starting it. You have organized a workshop in 2000 in Limerick. That was my first ICSE, and that was also the first time I thought, well, my topics might be suitable for ICSE. And thank you very much for that.
Yeah, thank you for keeping it going, and I'm sorry I wasn't there this year.
Okay. Anyhow, I have also a question. I think it makes a lot of sense to talk about design research because software engineering is very much about languages and tools and artifacts and whatnot. However, I find also design research gives a good advice if you start to intervene with real-world software engineering. And there somehow information systems complements often design research with action research.
Yeah.
So what is your opinion about that, or is that even more scary than design research?
You mean technical action research? Is that what you mean? Sorry, maybe I misunderstood the question. Do you mind repeating?
Not necessarily technical action research, but action research.
Just action research, yeah. I didn't go down that rabbit hole because it is a little bit of a rabbit hole in terms of it would have taken me another 10 or 15 minutes to talk about that. I think action research is really, really important. And actually, you know, these paradigms, they're an abstraction, right? You know, I mean, I think a lot of us in the community, and I like the way Ringa, I'm going to mess up his name too, talks about technical action research, you know, that it is that notion of we want to make a change, right? And I think a lot of us really do come at it from that perspective, where we want to make a change, we want to come up with an understanding or a prescription for a tool, and then distill from that knowledge that we can then share with others. So I see action research as another kind of paradigm that we can also fall under in terms of really caring about making a change rather than just caring about the knowledge. So it fits quite well with design research.
Thank you very much.
Yeah, you're welcome.
So thanks Maggie, for a great talk. I have a question. So I'm wearing like the industry chair, what do you call it? Industry program co-chair hat. And so the thought I have is people come from industry, they come for conferences to be inspired, right? To get crazy ideas, right? Kind of touching on this imagine more idea you have in there, right? And today our review process really doesn't enable imagination, right? Doesn't enable like wild ideas.
Yeah.
So have you thought of that? Do you have any thoughts on how we can, so it's more like write more, but actually enable imagination and enable people to take nice risks on their work.
Yeah. So the near tracks are supposed to be more about that, but I find
so the new track was started like that, but it was
now
more,
it's
more like dead ends that I don't know where to take it, so I'll just cut my losses.
Okay, so here comes the rant that I took off my slide. You know, this whole, it's like we're in this arms race with paper publications, and you know, when we have new faculty applying, new students that have just graduated, they have like You know, you think I have a lot of ICSE papers? Actually, John, I do not have a lot of ICSE papers. There are some people out here that have a lot, and some students that are just graduating, and I look at their CVs and I think, I would not get hired today. They wouldn't even look at my resume. I do not have enough papers. And so it is all of us, it is our responsibility to stop the stupid numbers game, you know, and to say, no, it isn't about how many papers. You know, a really good paper could take 2 to 3 years. Right, to work on. And I'm going to do a shout out to Klaus's 51-page TOSM paper. You know, I mean, I know it took you years, and it's amazing. You know, but it's only one paper, by the way, in your CV, right? It's one journal paper, right? So I don't know how to fix that, but, you know, we're going to stay. I mean, we're not irrelevant to industry. But I think we could be way more relevant, you know, to industry and in our research and have more fun if we stop that numbers game thing. And I see a lot of students, you know, presenting sometimes, or I see papers coming in, and it's all about the technique and not you can see there is no understanding really of what the problem is that the students are addressing or the new faculty are addressing, right? And it's because of this numbers game thing. Get the paper out, submit it, got to meet that deadline, right? And then it gets rejected, right? And then you have to submit it again. And then you switch a bait, right? Oh, maybe I get this kind of reviewer again, right? So I don't know what the answer is. It's way beyond me, but I hope the steering committee is really looking at this.
Thank you.
And we've got a question at the back.
Paul Robinson from Sony. Great talk. I'm encouraged by this sort of thing. Following on to, there was a closing keynote, I think, last year along similar lines. Rigor and relevance are wonderful things. I encourage them. What I'm coming here to find is something practical as a practitioner, something I can take back to my team, to my department, to my open source community. And quite often I go to a presentation that sounds promising and come away kind of vaguely disappointed. Is there some way that we can encourage things that are more practical, more applicable for practitioners?
Yeah, I mean, that was why I was very cheeky and gave the F to the ICSE Distinguished Papers, right? Because relevance from the design science paradigm is about being practical and about involving, you know, real stakeholders and showing that this problem is of practical relevance and the solution can be applied in a practical setting. So again, it requires a shift, you know, in how we appreciate that kind of work.
Thank you.
Yeah.
Down here.
Good morning, Peggy.
Hi. Hi,
I just want to, my name is Vio, I'm from IBM. I just want to follow up on your response to Danny Dick on
yes, thank you.
You know, how to collaborate with industry and what you do when you go to industry. I run a Center for Advanced Studies research program in Canada, and we have 53 research projects with all Canadian universities. Many of the professors in the room work with us. And from the industry perspective, from IBM perspective, when we engage with academia, and I might be biased because all our projects are research and development, so they need to combine the two. But when we engage with academia, we do exactly what your answer was, in which we bring our product teams and we have a room full of professors, and the product teams talk about their problems and the professors listen, and then research happens. And that's because, I said it many times, professors are very smart at transforming a product problem into a research question. But product teams suck at transforming a research idea into their problem that they have to face next day. So thank you so much for your answer. I think if you want to do research and development together with industry, we would benefit if you know, if professors would listen to our problems, because we know that professors will be able to transform those into great research questions. Thank you.
Thank you, Vio.
And at the back there, over there.
Hi, Hadi Amati from University of Calgary. Thank you, great talk. Just one quick possible solution for this imbalance that we have in the accepted papers. Isn't it possible to have multiple research tracks that they have caps, right? And if we have the three types, data papers and industry papers and whatnot, so we have 33% of the maximum accepted should be from this track, not more. So what is wrong with that to enforce the balance?
Well, that's a very post-positivist approach. Sorry. I don't know that you can put a number on it. I think it's, you know, I appreciate it. Maybe that's how we sort of fix the problem, you know, nudge it in the other way. But I think, you know, maybe program committee selection should look at broadening who's brought in and pay. Maybe there needs to be, you know, more attention by, you know, the program board members to really look at the reviews, because sometimes, like, the reviews, you know, like, I've seen things like, and I didn't get this personally, but somebody will have interviewed 30 people in industry, and the reviewer will have said, oh, well, you know, how did you, what technique did you use to come up with that sample, right? You know, and that's not enough to do statistics with, right? Or it's not enough to generalize. But that is a lot, to learn a lot about what's going on. And so it really comes down to, I think, better balance, a term, maybe across some gatekeepers, perhaps. Or just, you know, having maybe Chase should be a track, but then it's siloed, so I don't know. You know, we definitely need to try some different things, that's for sure. Yeah, thank you for the idea.
And we'll stay at the same mic. Yep.
Hey, Kim Hatzig from Microsoft. So I know we work a lot together, and I keep hiring new students, so thanks for that. But so what's your message to the industry? So how can we as an industry make your life easier as a researcher to engage with us? Because I hear a lot of people talk about, oh, we need to do better to engage with industry. But to be in all fairness, I think industry, and that means me and my team, often make it very hard for you to engage with us. So what's the other side of the medal, basically?
Yeah, so how do we get you guys to engage with us is what you're asking. So yeah, I mean, I think we need to visit industry more, right? Reach out, go visit companies, go. Something I haven't done, but I know some other people do, is they go to industry conferences. I guess I've gone to some, but not a lot. Walk around and talk to people. Boy, oh boy, are those exciting. I went to one ES day, right, at Microsoft. It was like, oh, I left there with my brain, like, stuffed with ideas. So I think doing that and then maybe connecting with people would be a good idea. But then it would be good if industry dropped the registration rate for some of those events, because it's hard to pay that, even for academics.
You drop the rate for ICSE as well? We
can
do that.
Sorry, I didn't hear that.
No, I mean, if you drop the ICSE rate for us, then we can talk about it.
Yeah, thanks, Kim.
We've got time just for one more question, so I've got a Jim down at front.
Jim Herbst, Carnegie Mellon University. First, fantastic talk.
Thank you.
Thank you. And what I'm curious about is the educational implications of your view. So it seems as though, and I worry about this, we need to teach our students some behavioral science, computer science, qualitative methods, interview surveys, quantitative methods, machine learning, statistics, plus they have to learn how to interact better with industry. How do we do that for the next generation?
This is a really good question. Actually, I gave a talk at the student mentoring workshop on Tuesday, and in that I suggested to the students that they take courses in the social sciences and on research methods, as well as data mining and statistics courses. And then, I mean, you can't have depth in all of those areas, but I think our students should have at least some knowledge of different kinds of research methods, and then build up the depth, depending on which area they're most interested in. And right now, that doesn't happen a lot. So I guess just, you know, encouraging our students to take these courses, or even have blended courses. right? Maybe computer science and social sciences could have a blended course. It's a great idea. I hadn't thought about that at all. That's a great question. Yeah.
So I'd just like to present you a little
Thank
gift
you.
on behalf of ICSE.
Thank you.
Don't drop it. And let's have a photograph. And let's thank Peggy again for a really thought-provoking talk. Thank you so much.